Good morning to all. In this lecture, I will solve some problem from IES preliminary question paper in the topic of electric circuits. So this is given in the year of 2021. So let me read the problem. A coil resistance 30 ohms and inductance 0.6 Henry is switched on to a 240 volt supply. What are the rate of change of current at the instant of closing the switch at t equal to 0 and the magnitude of the final steady state current respectively? Here 4 options are given. So from the question itself, we can find it is a RL transient circuit. So let me draw the circuit for that. What are the given values? Resistance and inductance. Okay. So this is a RL transient circuit. Resistance and inductance, and the given supply voltage is 240 volt. So this is 240 volt and this is switch S. At t equal to 0, switch will be closed. These are the given conditions. So resistance, inductance. Resistance value is given as 30 ohms. Inductance value is given as 0.6 Henry. Okay. So what is the question? Rate of change of current at the instant of closing the switch at t equal to 0. So the requirement is di of 0 by dt. I of 0 plus by dt equal to what? And then final steady state current. What is the indication for final steady state current? I of infinity. So we need to find di of 0 plus by dt and I of infinity. Okay. So here I'll solve the problem. So for the RL transient circuit, current through the inductor I of t equal to V by R 1 minus e power minus t by tau, where tau is the time constant and V by R, V is the given voltage that is given as 240 and R is the resistance that is given as 30 ohms. So we need to find the rate of change of current. So let me differentiate this current equation first. Di of t by dt. So V by R into 1, that is constant. So differentiation of constant is 0. So V by R into minus e power minus t by tau. So that will be differentiated as V by R into minus e power minus t by tau into 1 by tau. Minus 1 by tau. So this is equal to V by R into minus 1 by tau e power minus t by tau. So what is needed? di of 0 plus by dt. So di of 0 plus by dt is di of 0 plus by dt. So let me substitute t equal to 0 in this equation. When we substitute t equal to 0, e power 0 equal to 1. So this will get cancelled. So V by R into 1 by tau. So what is V? 240 and R is 30 ohms. 1 by tau is 1 by tau is L by R equivalent. So here L is a 0.6, R is 30 ohms. So 0.6 by 30. 0.6 by 30. So that will become 240 into 30 by 30 into 0.6. Okay, this will get cancelled. So 240, 2400 by 6, 400. So 400 ampere per second. Di of 0 plus by dt equal to 400 amps per second. Okay, so we found out rate of change of current at t equal to 0. So what is the next condition? The next question is final steady state current. So final steady state current is I of infinity. Okay. So at the final steady state condition, S is closed. So when S is closed, the inductor can be short circuited. At the steady state condition, the inductor can be short circuited. So this will become, the circuit will be like this. Because inductor is short circuit, this is I of infinity. So this is 240 volt and this is 30 ohms. So we can find I of infinity directly as 240 by 30, that is equal to 8 amps. Okay. So 8 amps is one answer, and 400 ampere per second. 400 ampere per second is rate of change of current. So see the options. 400 ampere per second is the rate of change of current and 8 amps is the final steady state current. So the option B is the correct one. Okay. And this is the next problem. What is the value of, the problem is, what is the value of V0 in the given circuit? So this circuit consists of one dependent current source and other one is independent current source. Dependent current source, this is given as 0.5 I0. That means this dependent current source, it is dependent on the current I0 which is passing through the resistance. Okay, this resistance. So let me solve the problem. Now we can take this nodal voltage as V0. So by the nodal voltage, by the nodal analysis, so here this current will be passing through this condition and here. So by this we can write the equation, that is 0.5 I0 by Kirchhoff's current law. 0.5 I0, this is the current incoming to the node V0. Okay, this is the node. So this is the incoming current to this node, and this 3 amps also incoming current. So plus 3, that is equal to I0. This I0 is the outgoing current. So sum of incoming currents equal to sum of outgoing currents. So 0.5 I0 plus 3 equal to I0. So simplifying this one, 0.5 I0 equal to 3, I0 equal to 3 by 0.5, which is 30 by 5, 30 by 5 equal to 6 amps. So 6 amps. If I0 is 6 amps, this dependent current source value, that is 0.5 I0, that is equal to 0.5 into 6, 3 amps. Okay. So what they asked, V0. So V0 is the voltage across the 4 ohms. So we can write this V0 as 4 into I0. V0 equal to 4 into I0. Okay. So I0, what is the I0 value? We found 6 amps. So 4 into 6, that is equal to 24 volt. So I found V0, the nodal voltage. V0, the nodal voltage as 24 volt by using Kirchhoff's current law. So option C is the correct one. Okay. Thank you.